a new technology and implementing the techniques. So by using these concepts, we can able to manage all the computer-oriented concepts. So that is the ultimate concept behind system engineering. So that was a tech which we discussed in the video. It came. The idea was created before 10 years back, and now it's available in the market. So please check it about the products of how a touch projection can able to project the video as well. You can type in and able to find the physical object into a digital world, taking your physical content into a digital world. Okay, that is the idea behind system engineering. So the some of the concepts we have discussed in Unit 1 about the system engineering. So today we'll start the Unit 2, structure of complex system. So what is system building blocks and interfaces in the concepts of system engineering in Unit 2? So it is totally going to discuss about complete system engineering factors such as building blocks and interfaces. Maybe you can say is interfaces. Okay? So there are major four factors which will be considered to create a best system. So one is program risk, and another part is technological performance limits. Then coming into the interfacing requirement and to make trade-off analysis among design alternatives. Okay. So these are the some of the four key factors that will create a knowledge among a system engineer. Should be sufficient to consider the factors of writing a program. Okay, create the new ideas and based upon the technology which is available. And the system engineering engineer must aware of interfacing requirements, and it is possible to provide an important insight into the structural hierarchy of a modern system, as well the type of different building blocks which is having we must have examined. So and the system engineer can able to represent the lower working level of technical understanding also. Okay, and at this level we can manage the two different activities. One is technical trade-off and another part is interface conflicts. Okay, so both are related to the working of a system building blocks, because when I create a system you need knowledge of programming as well, updated with the latest technology and try to interface the things into your system, and you must have the knowledge of design to reach the product into the market. Okay. So this is all about system building blocks and interface. For further readings, you can refer in Alexander Kosif and System Engineering Principle and Practices. So Unit 2 content and material is available in our Google class. Please read it. And another topic which is important in the complex system is hierarchy. Hierarchy of a complex system. So there are two types of systems we have discussed in the Unit 1. So one is complex system and another part is non-complex system. Non-complex system is a simple design or architecture related to one particular area, but a complex system which is considered as a multidisciplinary or multiple areas which is involved to execute a system. So what are the concepts of hierarchy of system? So the hierarchy of systems which is having for different analysis, we have different topics we can define in different structure. So just we can take a common in both natural and man-made systems. Okay. So take an example of physics. Okay, so there is a hierarchy in a physics. Always start from atom, then nucleus, then neutron, then proton, then it will be converted into the next level, electron. Okay, the nucleus have the three major components that is called as neutron, proton, electron. So which we used to say it is a atom. Okay, a system, a subsystem, and sub-elements. So we used to say it is a complete system, that is physics. Take a physics, it's full of atom. So in center we have nucleus, and nucleus will have the neutron, proton, and electrons. And when you go for any organization, any company or any big MNCs or maybe college or a university. So there will be a director. So who is controlling the overall system, and next level it will go to manager, and manager to general staff. So this is organizational system. And when you start reading a book always start from the chapter 1, unit 1, unit 2, chapter 1, chapter 2. And chapters have different sections, and different sections have different paragraphs. Okay? So this is a great example for understanding of a hierarchy of a system. A complex system always have multiple hierarchies, start from core to that is center to the outer layer and outer to the inner layer. And model of considers a model of a complex system which have the number of major interacting elements. And majority of systems are developed by integrated acquisition process. So coming to the system level, we have different categories in natural as well human. That is a man-made system. So, but coming to the system engineering in the point of view of a computer science engineer, a system will be taking to the next level and leads to the next level. That is subsystems, components, subcomponents, parts. Okay. You take a car. So car have more than thousands of spare parts, but all these spare parts are connected to the main heart of the car. We used to say it is a engine. So engine have different parts. All these subcomponents are connected to the main component that is coming under to the driver control. We have accelerator, brake, and clutch, and steering wheel. So these are the main components and subcomponents which will be connecting, and everything is controlled at the level of driving. Okay, so a car have the subsystem, so accelerator, clutch, and brake, and components, engine, tires, and tubes, okay, and parts. All the space parts will be called as a small system, a automobile system. So first you take a system. So what is the system? System must possess a property of engineered system and should perform significant useful operation with the help of human operator and standard infrastructure. Example, power grid, fueling station, and communication lines. So according to the concept of the system, to what are the above conditions we have discussed, we can take a passenger aircraft or a personal computer with input-output device, CPU, mouse, and keyboard. Anything can fit into this definition. System must have properties and significant operation. That is called as systems. So what are subsystems? Subsystems is very simple. Okay. These are subordinate. Okay, director will be there in the college or maybe a MNC. So followed by director, we have manager. The manager is the one of the subsystem. Okay, we have main system, subsystem, so components, subcomponents, and spare parts and parts. So the major portion of system that perform the closely related subset of overall system functioning may be complex itself, and these may have properties of system expert being able to perform useful function independently without other systems, involve several technical disciplines. So these are some of the futures in the subsystem in a system engineering concepts. Okay, subsystem is simply we say it is a subordinate, okay, and most of the complex operation will be done by the manager. And third one is component. So what is component? It refers to a middle level of the system. So between, in between manager and staff, we have supervisor. So that is called as a very simple example of a component. Very simple example in between CPU and input unit. We have control unit. So the control unit is one of the major component to control the transaction between input unit and output unit. Okay, and subcomponent. So what is this subcomponent? So these are the building blocks. Okay, when you take a computer, we have input device, keyboard, and mouse, and the output is a monitor. In between, we have motherboard. In motherboard, we have microprocessor, RAM, ROM. All these are coming under subcomponents, okay, which is below the component building level. Okay, which will be performing an elementary function or composed of several parts. Okay, the subcomponents of any system that will be always performing lower level operation, but it will help to do the transactions between input and output devices and parts. So what is parts? Everybody knows spare parts. Each and every nuts and bolts of the computer, that is called as spare parts. These are very lowest level. So maybe staff we can know, attenders and operators may help to function properly the system. So like that, in a company, employees category divided into different parts. So that is called as lowest level. So staff, manager, director. Okay, parts, subcomponents, components, and subsystem, then system. So this is coming under in engineering concept. Perform no significant function except in combination. There is no scientific operation, only supporting. And great majority comes in standardized size and types, can be bought commercially. Okay. Everything is available commercially. For example, if your mouse got repair, you can purchase this part at low cost in the market. Suppose you have problem with webcam, you can purchase one webcam and you can connect with your system. And if you want LED light, you can connect with USB LED light. So these are commercially can purchased outside. You cannot modify. You cannot modify in your computer. You have to purchase compulsory from the outside. So those are called spare parts. In cars also. Cars also we have headlights. If anything is not functioning properly, you can purchase new headlight and you can connect to the car. Okay. So this is a basic idea about parts. These are lowest level and it can be purchased commercially. Okay. So this is a final typical structure design hierarchy, and we'll see some of the example and we'll wind up. A system. So you can see communication system. There are 4 systems here you can see. So those are communication system, information system, material processing system, and aerospace system. Okay. So we'll see one by one. You will get clarity. So what is system design hierarchy? So subsystems. Okay, we have subsystem for communication system is signal network. And when you go for IT, it is a database. And when you go for material system, it is material preparation. And aerospace, we used to call engine is the subsystem. And which is component in a communication system? Receiver. And information system, data display component. Your LCD monitor, LED monitor, all are component in the information system. And material processing system, power transfer, and aerospace thrust generator. Okay. And subcomponent we can say in communication system, signal amplifier. And subcomponent in information system in a computer. So the component and subcomponent of data display is CRT, cathode ray tube. So if the CRT work properly, then only you will get display. Okay. And material, power transfer, aerospace, thrust generator. Similarly, gear trains and racket nozzles. Okay, power transfer, thrust generator. So one by one, engine, thrust generator, racket nozzle. Database, data displays, CRT, and LED. Okay, and communication system, we have spare parts, transformer, and material processing gears and aerospace seals. Okay, so this uh, design hierarchy and this example will make you clear understanding. So what are the concepts behind the system design hierarchy? And domains of system engineering we'll discuss tomorrow. So today what we discuss is system design hierarchy. So there are different levels in system, subsystem components, subcomponents, parts. So tomorrow we'll discuss about the domain. Okay, what is domain and how it is used for the domain levels. So any doubts, please ask me, and please post the queries in Google Class. Any doubts, any queries. So any doubt, you can ask anytime, no problem. And let us check what is happening in our Google Class, because after a long time we have joined. Just we'll recap. So what is happening in our Google Class? Yes, we have uploaded our Unit 2 PPT is available. So please read it before come to the class. It will be easy for you. And some of the Nilumbus technology have some advertisement you can go through. Okay, and okay, yeah, something IET, something I shared, you can join. And Brainovision, okay, some of the activity we have done. Classwork, we have done one assignment. Very soon I will share another assignment. That's great. All the 56 submitted the assignment. Okay, that's great. Okay. Mm. So soon I will share the second assignment also. Soon we will have activity in Unit 1 also. Okay. So fine. So please follow the Google Class. Okay. And please download the material. All the materials, Unit 1, Unit 2, all the materials available in our Google Class. Please read it before come to the class. And yeah, so Kitan, yeah, Kitan is there.
Sir, sir, yes,
Yeah,
sir.
good evening, Kitan. So after a long time, we resume back to our class. Huh?
Yes, sir.
Fine. You please send me the absentees. We have very less number today, 38 only. Maybe because of
Yes.
special class. Everybody know now? Enable.
Yeah, yeah. No, no, sir. Few people didn't activated their accounts, so that's why.
Okay. Fine. So no issues. If please share me the absentees, I will update it.
Yes.
Okay. So tomorrow we'll join in the same time, 4 o'clock. Okay. Okay, fine. So any doubt, please ask the students to ask me or post the queries in the Google Class. Okay. Okay,
Okay, sir.
Kitan, please share the
Yes.
attendance. Huh?
Okay, sir.
Absentees. You have noted, huh?
Sir, I took screenshots, sir.
Okay, fine. You please share it. I will also cross check. Okay.
Yes, sir.
Okay. Thank you. See you tomorrow. Okay. Anything. So be kind for yourself. First, you have to be kind for you and yourself. Be yourself. Okay. That is very important. So if you are not kind enough, then you will be facing a lot of difficulty in your life. Okay. So in my opinion, try to be kind and try to be positive and do something useful for you. Okay. So till only 31 joined. So we have 56 students in our class, but we have only 31. So maybe the remaining are maybe in depression. I don't know. So just I'm kidding, but okay. Don't be depressed for any reason. Okay. If anything you feel, speak out. Okay. So yes, we want to stop this class, or you want to talk something else. You want to share something. Okay, you can speak out. This is your class. You can speak out, or if you don't want to speak, you can share your thoughts in our Google class. Okay. So let us start the class. We can resume back to our class, the concept behind the structure of complex system, which we discussed in the previous class. Okay. Well, we have discussed the hierarchy of a system building blocks. As well, we have discussed complex system. Probably we have discussed the concepts of hierarchy systems. Okay, most of these concepts have some levels. Okay, systems, subsystems, components, subcomponents, and parts. Okay, so these are the some of the examples we have discussed in the previous class. So this is just a recap, and most probably we will be discussing the next topic is domains of system engineering versus domains of design specialist. Okay. So who is system engineer domain and who is the design specialist domain? Okay. A system engineer domain will have the three views. extend down through the component level is as detailed as system engineer usually needs to go, and extends across several categories. Okay. One who want to become a system engineer, according to the domain, consider maybe network, or maybe intelligence system, or maybe image processing, or maybe a bioinformatics engineer. Okay. He or she must have the knowledge of component level. In component level, they must go through and go extend down through the system analysis on particularly in this area, as well across the several system categories. And one who want to become a design specialist domain extend from the part level up through the component level and overlaps the domain of system engineering at component level, is usually limited to a single technology and discipline. Okay. If you want to be special on particular area, you want to become a musician, or you want to become a software developer, or you want to become a scientist. Okay, so that is being considered in this concept, a design specialist domain. Okay, particular design, he is special on the particular, or maybe a expert on the particular field. So that will extend from the part level up through the component level. Okay, from part to component. Okay, and to add more for these kind of concepts, we have the overlap area. Okay, so that can be a not in all the area, so it stick to the particularly area. So what are the essentials of that domain expert, or a person specialist? Okay, he or she must be communicate effectively. If you want to become a good system engineer, or you want to become a specialist, you must communicate. You must talk. Okay, you should not switch on your Zoom meeting and you cannot sleep. Okay? You can talk to your faculty, you can interact with your faculty, or at least you can text. Okay, you can text in Google Classroom or Piazza.com. Okay? So maybe you may simply switch off your mobile phone or laptop in mute mode, and you can do some other activity. It depends upon you. But being a good system engineer, you must talk. Okay, you must talk effectively, and communication should be perfect. And identify the discussed technical problems. You can able to identify problem. If you are studying in final year, okay, you have to do some project in your final year, but you have to identify the exact problem. Okay, and you have the knowledge of negotiate workable solution that will not put system design process into risk. Okay, so whatever the solution you are giving to the company, or if you are going to work in MNC, the solution which is given by you should not having any risk. Make sure any idea, any product you want to develop, so that should not put the company into trouble. That means loss. Okay, you should work for the company and make profit, and he or she have to make sure that the capabilities of system as a whole should not be at risk. Okay, you cannot create an atom bomb which will be going to which will be leads to the negative point for humanity. Okay, whatever the system you are creating, that should have some good lead, not a bad lead. You should not destroy anything. Okay, anything you are creating, you should not create any risk. Okay, that thing you must make sure. Okay, being a good specialist in the system engineering, first point you have to communicate, and you have to able to identify problems, and you have to negotiate the solution, and you should not put the system design process into risk. Okay, so this is a typical architecture or a design of knowledge domains of a system engineer and design specialist. You can see closely. Okay, You are a system engineer, you are here in the top left corner. Okay? So you can work in two direction. Okay? The first initial two direction, uh, system and subsystems. Okay? One part in the system engineer, you are the part of the system, and you are controlling the another part of the system is called as subsystem and components. You are responsible. Okay? You are going to create a new software for agriculture department, or maybe a pharmaceuticals company, or maybe automobile. So automobile consider is an example for system and subsystems, engines and spare parts and body and fuel. Okay, all these energy signals, data, materials, energy. Okay? So these are the subsystems for a particular area, knowledge domain area. You can select automobile, you can select a computer science, or you may be a ECE, electronic communication engineering student. Okay? You must have the knowledge of components, subcomponent, and parts. System is a whole, considered a communication system, so which will be having subsystem, signal, data, material, energy, and components. Maybe here in the top level we can see it is a system engineer, and in between the parts to subcomponents and subcomponents to components, we have the role of design specialist. Okay, so parts and through components, and subcomponents through components. Okay, so here the specialist have the major role. Okay, the specialist may be a optical, or a software specialist, or maybe electromechanical specialist, or a mechanical specialist, or a thermomechanical specialist. Okay? So most of the specialists are working in this area. Development in software, we say it is a development team. Okay, 70% of budget is spent for development, and 30% is spent for maintenance. This is the normally it's happening in MNC company. So this typical structure shows what is the role of a system engineer and what is the role of a design specialist. So got it. So this is the reference. Again, you can go through the concepts which is available in the Alexander Kosich and William Menn suite. System engineering principle and practices, Villa India, chapter 3, page number 42 to 45. So please go and refine any doubts you can ask. Tomorrow we'll discuss system building blocks. Okay. So any doubts in today concept, as a system engineer, as a design specialist? Okay, we have the two major role, engineer domain and specialist domain. Okay, so this is all about today's topic. Okay? So tomorrow we will discuss with another topic, and we will be who is actually system engineers and who is the specialist on the domain. So he is a very good example for system engineer domain. He is one of the specialists in manufacturing the product of connecting two different world. That is physical object and digital object. Okay, so physical world to digital world. That is the idea behind the great work of good system engineering. So what are the other features of what we are discussing in Unit 2? So what are some of the features of the system engineering? Building blocks. Okay, so the building blocks have the different concept. As we discussed, so building blocks concept have the library of commonly occurring system elements. It has a huge library where you can select the different number of items or different number of ideas where you can use it for different characteristics such as functional and physical. So there are major two categories when you create a system. So one is functional characteristics and physical characteristics. A useful tool for modeling system architecture and synthesis, which is useful for visualizing potential architecture of system concept. So that is a major concept behind building a block by using a system engineering. System engineering giving the solution for making functional as well physical. Okay, that is physical and digital. So how we understand the concept from the video, like Pranav Mistry, we have the two characteristics can be classified in a system engineering. So one is functional, and another thing is physical. Okay, so we'll go to the next slide, and what are the some other concepts which is related to the functional building blocks. We have one is functional and we have one is physical. So what is functional building blocks? So information, material, energy, okay, and signal, data, material elements, and energy elements. So these are some of the example. But the basic three entity is information, material, and energy. Okay. So these are the basic, very basic entities for processing the functional building blocks. Without these, we cannot do anything. And some other four system functional building blocks are, okay, which is coming under signal elements, okay, that is sense and communicate, information and data elements, which is very important for a system engineer to interpret, okay, and to organize and to manipulate the information. And the third one is very important. We need material, the material elements. Okay, without material, we cannot do. So in video we watch now. So Pranav Mistry is using the mouse. The basic step he tried with information, material, and energy. Then he started using camera. Using the camera, he can able to identify the objects in physical world, and he was trying to make it is in the digital world, made available in the digital world. So that's why material provide the structure, transformation of materials. And very important thing is energy. Energy is one of the important system functional elements, okay, which is having the part of providing the energy and motivating the power. So these are some of the basic terminologies you must remember. These are coming under functional elements. So we will see what are the concept behind the functional building blocks. How we can use it. Okay, so there are major three basic concepts. One is significance, singularity, and commonality. Okay, so these are the other three important concept behind the functional elements. What are the functional basic information, material, and energy? Similarly, we have functional building blocks elements. Significance. Okay, what is significance? It is going to play the vital role and functional. Each function elements must perform a distinct and significant function. And singularity, which is going to be a largely within a scope of single engineering discipline. It's a single engineering discipline. And commonality, so which is going to identify what are the common hardware or maybe a software characteristics found in a wide variety of system types. So this is the other important three functional elements: significance, singularity, and commonality. Okay. So what are the signal function elements available? For example, if we considered any a smartphone, or maybe your micro oven, or maybe a Wi-Fi device. We consider Wi-Fi device which have input signal. Similar TV camera also, we have input signal. And transmit signal, very good example, we have radio transmitter as well remote control, okay, so which will receive and transmit the signal. And transduce signal, okay, these are the left side you are seeing is a functional, which is going to do some function in the device antenna. And receive signal, radio receiver, and process signal, image processor, and output signal in the TV dish and speaker. So this is what we saw in the video, where the Pranav Mistry is using a camera and a transmitter, and he have internet connection for antenna and radio receiver, and he has one image processor, and he is also having display. The display and speaker, maybe you can use it in any walls or any paper, so based upon your need. So these are some example, very good example for signal function elements. And what are data functional elements in a system engineering concept? Input data, keyboard, we need keyboard in a computer, and CPU which is going to process the data, and operating system, Windows we are using for control the system, and word processor we are using for control the processing, and how where we store the data, magnetic, okay, magnetic disk, and how to take printout or how to take the output. Okay, we can use printer and display. Okay. So this is a two different characteristics we saw in the video: physical world and digital world. Okay. In physical world, we have keyboard, CPU, mouse, etc., etc. And functional in world, we have input data, process data, and control and store the data. Okay. What function we do with the help of physical devices? We have physical devices, and using the device, what we will do? Keyboard, we will give input, and printer, we will get out. So these are data functional elements. And coming to the next level, we have material functional elements. We have different materials, for example, airframe, auto body, container, autoclaves, milling machines, welding machines, auto to field. What are the material? These are the material example. What the function it does? Okay. So airframe and auto body used for support material, and container, big container you can see in airports or maybe in other places to shifting operation. We use container, big container. Okay, we use the container to store the material, and autoclave and smelter use react material. The milling machine which is used for foam material, and welding and riveting material which is used for joining. You may saw this welding while you are traveling across the road. Many places you can see the welding. So welding is widely used for the function to join two materials. Okay. And control position, it is auto to field and power steering. Power steering, everybody know. In your car, we have power steering, which is used to control your automobile. Okay. And coming to the energy function elements, we have different examples: rocket, turbojet, gas turbine, power plant, solar cells, furnace, and refrigerator, transmission, power brakes. So these are the physical example for energy. How we will get the energy by using the energy? What is the outcome? What is the function? So rocket will generate thrust, and gas turbine will have the function generate torque, and power plant and solar cells will generate electricity, and furnace and refrigerator will control the temperature. Particularly we need to control the temperature, we need refrigerator and furnace. And control motion which is done by transmission and power brakes. So power brakes are widely used in automobile industry too. Maybe in your two-wheeler or four-wheeler, you can apply the brakes to stop the vehicle. So these are the functions in energy function elements. So this is in on hold. So what are the system functional elements? We have four categories function. One is signal, another thing is data, and third one is material, and final one is energy. So these are the different four categories of system functional elements where we can use it for different physical objects. We are in physical world. We have physical materials, physical products, and it does different functions based upon the class, which class you are using. Maybe you can use signal, or you can use data, or you can use material or energy. Okay. And coming to the another concept that is called as physical building blocks, components. What is this components? They are the physical form of functional elements consisting hardware and software. So now we are going to the components. So what is the configuration of your mobile? What is the configuration of your laptop? What is the functions of your automobile car. So we used to features of your refrigerators. Okay, everything is called as a component. A component have the both concept, one is hardware and software, and have same characteristics, significance, singularity, and commonality. These three concepts are very important for all the components you are having, referred to as a component elements or simply component. And some components like electronic, electrooptical, and electromechanical, and mechanical, thermomechanical, and software. So these are some other components which have in different field. In our field, we use hardware and software as a component. You can see a physical world example, a physical building blocks. And we know the example receiver transmitter. It is for electronics, and optical sensing fiber optics cable, which is used for high speed internet, electro optic, and electric generated data storage transducer, which is used in electromechanical. Okay, and mechanical field we use container, material processor, and other items to store the data, store the materials. Thermomechanical, everybody know thermodynamics used in jet, rotary engine, heating, and ACs. We need the thermomechanical category. An operating system application which is used in software and firmware. It is related to computer science. Remaining are related to ECE and mechanical. Okay. So how can we design the components? You hope you got some idea and clarity about the components. Design elements have major categories. Depends upon the components we are using. We may use software, we can use hardware, or we can use signals, or we can use some kind of jet engines, okay, rockets, okay, or you can use the AC or a refrigerator. Everything have different functions based upon the different fields and based upon the different components. Okay. So these many components are there listed in the PPT, which is used for a different purpose. Okay. So all are having specific operation. Okay. And one more concept we have, that is applications, where we can use these building blocks, applications of a system building blocks. So it is used for achieve the outcome. If you use AC to maintain the temperature, you use refrigerator to maintain the cooling efficiency, and we need components for connecting different interfaces and helping the software engineer to gain hardware knowledge. These are the some of the applications of system building blocks. References, you can please go and refine system engineer principles and practices, Villa India, chapter 3. System environment we will discuss tomorrow. So our course is very interesting course, and it have a lot of concepts. Okay. Please go and refine, and very easy subject, you can score good marks. Today we have discussed system building blocks, which have the different characteristics, functional and physical. Okay. So this is the concept behind how we are executing the input and output by using the different technology. Okay. So any doubt you can please ask me. Today we got around 46 participants. So the PPT is available in Google Class. Please read it. Any doubts, and soft copy of book is available in our Google Class. Please download and read it. Any doubts, please ask me. Feel free to ask, post queries in Google Class. Okay. Stay safe and stay home, and also any doubts you can ask me anytime. And Kitan is there. Hello,
Sir,
Kitan.
sir.
So please send me the answers of today. Okay,
Okay, sir.
we'll meet tomorrow, same time. Okay.
Sure.
Okay. Okay.
1 minute.
See tomorrow with another
Sir,
topic, system environment. Yeah, yeah. Tell me.
so 1 minute, sir. I'm taking screenshots.
Yeah, yeah. Please, please. So I request everybody to read system environment tomorrow, and we will discuss. Okay. So we have very interesting topics tomorrow. In coming future classes also, we have a lot of interesting concepts. Okay. Read it as a system engineer. Please read it. Any doubt, please ask me.
Yes, sir. I'm done, sir.
Okay, okay. See you tomorrow. Hmm. Bye, Ketan. Thank you, thank you, thank you.
Okay, sir.
Set up your own company. Okay. You should become a boss for your own company. You forget about the story you are going to work under somebody. Okay. So being a system engineer, you can build your own company, own setup. You can become a good entrepreneur. Okay. So everything is based upon how you are working. So what you are focusing. So similarly, in our course also, we have studied system building blocks, okay? How the function elements and how it is related to the physical and functional parts of a system. A system must have physical and functional elements. Okay, how we observed in the previous video, the message is about how to take this physical world object into the digital world. So we need a good system environment to create a better system engineer. You want to become system engineer, you must have the knowledge of environment, where you are working, what you want, what is your role, so how to achieve your goal, so what are the major characteristics you need to achieve your goal, okay? And how to come out of the failure and how to create a new system. Okay. We have the another concept behind the system boundaries, development control, operational control, function allocation, and unity of purpose. So these are the another point of view for creating a better system environment. A system environment must have all this development control. You need to focus on what you are doing, how to develop your skills, how to get a start with an own company. You forget about job. Now onwards, you forget about going and begging for job. As a system engineer, you must have the knowledge of creating your build your own company. Okay. You become an entrepreneur. A lot of opportunities are there. So please focus on how to develop control on the system. Okay. It is not just an easy job to identify is the part of system and what is a part of the environment. So we have to create a certain determining criteria. Okay. So does the system developer have control over the entity development? And does the developer has a role in defining the requirement or not? And is funding a part of developer budget or some other organization? Okay. These are the three different point of view in a development control. As a system developer or a software programmer or a system engineer, you must have control on your development and requirement, what you need, and the budget, how much finance is required to start up your own company. And apart from that, another part is once you set up your company, you must have the knowledge of operational control, how to operate your organization or your job or your role or your goal, how to operate to get best out of from your organization. Okay. So there may be some of the task which is can be directed the owner of the system, and will another organization have the operation control at times. Everything you have to think how to execute. That is the operational control. And some of the other two system boundaries, functional allocation. How the resources are being allocated. As a system engineer, allowed to allocate the function to the entity in the functional definition of the system. Okay, he has the potential. He literally he has the energy to allow the functional to functions to process. And last but not least, unity. Unity of purpose. Is the entity dedicated to the system success? Once it is filled, can the entity be removed without any objection by some other entity? Okay. So there will be a partnership on purpose. Okay, is entity dedicated to any system success? Definitely, human users and operators are often treated as external entities. Okay, focus in the operator interface and still important in functional acceptance. For example, you can consider network of roads and service and stations. Okay, you can see. So Hyundai service centers or Maruti service center. Okay, across India. So we have different service station. So wherever go, which city you travel, you have a service station, networks of roads. So this is how we operate a system. It is not stopped once you sold the car. It is not stopped there. You have to give the support for service. If you own a software company, your work is not stopped by developing. You have to give maintenance support, okay, for the software which you sold the person who is purchased your software. So these are some of the great example for how to create a system boundary, how to create an environment. First, you have to start a protection unit to make the car. After making the car, you need a sales center to sell your car. After sales, you have to give the service support across the globe. So then only you will be get a big success in the market. Okay. So that is a great idea behind how big entrepreneurs are developed. Take the example of Alibaba owner or Amazon CEO or Google CEO. So everybody is working behind these concepts, network of roads and service stations for different criteria they are using. And apart from that, we have another interesting concept is context diagram. Okay. So what is this context diagram, which is giving a complete display about the external entities and their interaction with the system. Okay. Once your job is done, then you must have the communication with the external world, okay, and how they are interacting with your system. Okay. Suppose I have purchased a Hyundai car, okay, but still my car need the service support, and how the service people are in touch with me. Every 3 months or 6 months they will call me and they will verify the condition of car. So continuous monitoring, so that is important, that is called as external entities, sources of inputs in the system and destination of outputs from the system. Okay, and interaction, so represented by arrows directed or flows of particular interaction. So the context diagram will give a complete picture about the system, that represented by an oval, circle, or a rectangle in the center with only name of the system within. I will show the example for a context diagram. This is the context diagram. So consider the system is automobile. The external entity, we have different people. The external entity is a manufacturing unit and a service station and sales station and customers and materials. Okay. So these is the very good example for a context diagram. So material data, signal data, energy data, and activity of material and activity of the data. Okay. We need data, we need activity, we need materials to connect with the system. Those are called as external entity, materials, signals, energy, and activity. So in the this is a typical structure for an automobile industry. This is a general overview. As I said, we need to understand the context diagram must have maintenance, environment, energy, user. Okay, these are the different four point of view of a context diagram. So what the user expectation? So he always expect the status of auto, status entertainment and temperature control air and cargo. Apart from that, steering, braking, acceleration, light command, windows command, voice command, horn, temperature. These all will be connected with an user. And maintainer will have the spare parts and he will identify the errors. And automobile, another part is environment, how to create heat, siren, exhaust, light, support, resistant, weather. Okay. in rain, what will happen in during hot condition, what is the effect. And source, everybody know it's gasoline or petrol or diesel. Okay, so these are the 4 point of view. We need customers, we need a maintenance unit, we need to create good environment and energy source. These four put together, we say it is a context diagram for an automobile. Like that, you can create a context diagram for your project, or for your software, or for your electronics unit. Okay? So everything is based upon the complete picture. So what are the types of environmental interaction? There will be a three major categories: input, output, system operator, operational maintenance. The input output, everybody know it is the concept behind how the external material such as manner or process in the input is a useful way, and system operator emphasis on human machine and complex to define the test. And operational maintenance, readiness and operational reliability provides access for monitoring, testing and repair the equipment. These are the three major, very basic steps to identify the types of environment. Another next 4 point of view of environmental interaction: threat. So threat is very important, maybe man-made or natural. So man-made for a car is theft, and natural is maybe in form of fire or rain or some other intruders. Supporting system depends on carrying out its mission. Okay, it's a part of infrastructure. System housing provide the protection. Okay. So once your car is purchased, you have to keep it in particular place, safe place. And very important thing is shipping and handling. Once your product is ready, it should be delivered to the customer. Okay, that is from manufacturing site to operating site. Manufacturing site may be in somewhere in Delhi or Noida, but operating site may be in South India, maybe Tirupati or Chennai. So the product will should be shipped safely to reach the customer hands. Okay. So this is another example, a great example, and diagrammatic representation of passenger airlines. Okay, that is ILS, Instrument Landing System. Okay, so during rain, we have turbulence, wind turbulence. It's a big challenge to operate the flight. Okay, all the signals should come from the base station. If there is no signal, then it is very risk to operate the flight. Once signal is disconnected, then all will die. Okay, so that is very important for a flight environment. And we have to create a landing environment which maybe have the risk of shock and vibration. That also based upon radar. If the radar signal is gone, we could not land. Again, the passengers will be in risk. They may chance of die. Okay. And after landing, so while flying, there is a risk of winds and turbulence. While landing, there is a risk of shock and vibration. And while coming back to the land, we need to refuel. Okay. And people and payload interface. This is the another part: interface and maintenance. Okay, so the passengers will be accommodated and they will be allocated the seats. And before start the flight for takeoff, they will verify each and every parts maintenance environment. Okay. So this is a different 6 steps where we have to operate the create a good environment to operate the system. So references, you can further readings, you can verify system engineering principle and practices well in India, chapter 3, page number 51 to 58. So please go and refine how these environment is very necessary for creating a good system. If the working environment become toxic, then faculties and students may not be happy to work happily in the environment. If the government is diluted, the system of government is not good, then people will suffer. So that's why this particular topic is meant to say, for a good system engineer, the environment is play the vital role. With a good environment, Suppose you are attending Zoom classes. If you don't have good environment, maybe you are traveling in bike, you may listen the class, or you are sleeping on the bed. You cannot completely focus, or maybe you are watching the TV and listening my class. You don't understand anything. Okay, so for a student, he need a good environment to attend the class. Okay. Similarly, so faculty also needs some good salary to take care of their job and other things. Okay. Similarly, in government sector also we need a good system to take care of the people life. Okay. So development control, operation control, external entities interactions. Apart from we have learned something about input output. Okay. And threat supports housing, shipping, and handling. Okay. This is a very interesting topic. You must listen, okay, and go and refine. Okay. So because being a good system engineer, you need a good environment to work. Okay? Because you cannot create a good system when you are working or living in a remote village. You need an environment like MIT, Manchester Institute of Technology. We have discussed in the previous class. Fine. So next concept we are going to discuss is physical building blocks, application system, system environment we have discussed in the previous class. So now we can able to discuss the one of the major concept in system engineering is interfaces and interactions. So what is interface? Okay. External. There are two types of interfaces we can use with your computer system is external interface and internal interface. When you use cyber security concept, which we watched in the video, there will be a external and internal interfaces will be there. The external is the internet connection which you are using, and internal is whatever the device or software which is running in your mobile device. Okay. Mm. Such boundaries are called, all the interaction occur at various boundaries of system, different boundaries. Okay. Each and every system have boundary. Okay. That such a boundary is called as external interface. And how the management of interface involve identification and description of interfaces as system concept definition, and coordination and control of system integrity throughout the system development lifecycle. So there will be boundaries between individual components form of internal device interfaces. Each and individual components such as microphone and your camera and sensors, okay, and memory and ROM, RAM, all these are called as interfaces, which is connected to the system. How it is interact? So take place through the interface connecting the two individual element. Okay, so connecting your smart TV with your mobile phone, connecting your computer with mobile phone, or connecting your mobile phone with a Wi-Fi printer. So everything which enables driver to guide by transmitting the force that turns the steering. Okay. That is the driver's hand of steering wheel, which is going to control the activity turns the car's wheel. So if you control your steering, that will be the direct control of your steering, which interacts with the wheel. So this is called as interaction. Okay. How it is interacts when you click on Wi-Fi button in your mobile phone, that will be interact with the nearest devices, Wi-Fi devices such as Bluetooth speaker, Wi-Fi speakers, Wi-Fi printers, Wi-Fi routers. Okay. So this is called interfaces. And what are the elements of interfaces? We have connectors, isolators, converters. So these are the three different elements of an interface. What is connectors does? Which facilitate the transmission of electricity, fluid, force, etc. between the components. Okay. And isolators which inhibit such interactions, converters which alert the form from the interaction medium. So isolator is going to inhibit such interaction, and converters which is used to convert encoding, decoding, or readable, human readable format into machine readable format. All this conversion is done with the help of converters, and these interfaces are relatively simply. A large fraction of system failure occur at interfaces only. Some of the examples which we are seeing in the screen, there are different types of uh, we have electrical, mechanical, and elements. We have different types of elements and hydraulic and human machine. And we have the another four types of interfaces. That is connectors, isolators, converters. So take the electrical current. When it is in the name of connectors, it is called as cable. And mechanical, it is joint coupling. And hydraulic, it is a pipe valve. And human machine display control panel. So this is called connector in different streams and different elements. And we are using isolator. In we'll see in electrical, it is called as radio frequency shield insulator. And mechanical, it is called as shock amount bearing. And hydraulic, it is named as seal. And coming to the computers, so isolator is called as cover window. And converters in electrical, it is called as antenna, analog to digital converter. We use for watching the movies. Okay, in all the houses we have antenna. Okay, particularly for television. Okay. Dish TVs we are having these days, and converters in mechanicals, gear, train, piston. We use piston as a converter. And hydraulics, reducing ball pump, and in human machine it is keyboard. So keyboard which is converting your input in binary form to human machine readable format. That's why it is called as so converters. This is a very good example for interface elements. How interface is having different activities in different streams. Same connector, isolator, converter, but it have different roles in different streams. So this is the reference for the today's topics, converters and interfaces, connectors and interfaces. Alexander Koshif, William Sweet, and System Engineering Principle and Practice, Ville, India. Chapter 3, page number 58 to 60. Please refer. Please go and refine. Okay. So tomorrow we'll discuss the next topic of process of system development. So any doubts in today's class, let me know. So please post the queries in Google Class about interfaces and interactions. So all the concepts are very easy concepts. Please read it in home. Okay. So any doubts, please let me know, and we will discuss. So please be prepared for tomorrow class, and please read the content. So tomorrow contents is very important. Process of system development. It's a very important topic in system engineering. Please read it before attend the class, right? And so for any doubts, please ask me, and startup company. So if you have good idea, you have good future. Okay. So that is the process of system development. How the development of wireless transmission of energy, there is electricity, is done is based upon the process of system development. It is a set of activities, method, best practices, deliverables, and automated tools that stakeholders use to develop and continuously improve the information system and software. So this is the concept behind the system development process. A system should be developed based upon set of activities, not a single activity. So in 1890s, it was an idea of Tesla to create a wireless energy transfer. Okay, we can switch on a bulb by transferring the energy wirelessly. That there is no more wires. Okay, so think about the future world. So similarly, so it is called as automated tools, okay, and develop and continuously improve the information system and software. Many variations, which means that consistent process for system development create efficiency that allow management to shift resources between project. So the different projects are there. In the particular video we observed, so there will be the CAC will be part of there, and electrical people will be there, ECE will be there, and mechanical people will be there. Okay, so there is a shift of resources between the project. Okay, most of the resources are used by different technology and produces consistent documentation that reduce the lifetime cost of maintaining the system and promotes the quality. So these are the three major consistent process of for the system development, right? So life cycle versus the methodology. So what is life cycle? The concept behind life cycle is having two stages: system development and system operation and maintenance. First, we have to develop the system, then we have to operate it, and we have to maintain it. First, you have to develop a software. For example, railway reservation system, there is a software is there. Then for operate the software, we need people, system admin, software developer, and maintenance managers and end users. Okay, so after that it will be going for the public. Okay, the system development methodology is formalized to approach to system development process, a standardized development process that defines a set of activities. There is a lot of activities involved in railway reservation system and wireless transmission of energy and Bluetooth technology, wireless technology for internet communications. Okay? So everything is based upon the continuous improvement of information system and software. So this is the architecture behind how a system life cycle is working. Okay. And what will be the lifetime of a system? Conversion and obsolescence. Okay, converting from existing technology to new technology and removing the vulnerable. Okay, what are the vulnerable in the system? What are the demerits of the disadvantage of the system? Those things will be removed. That is called as obsolescence. So updating to the new technology. So this is a continuous life cycle, a system development process stage, and another stage is system operation and maintenance. Okay? So obsolescence is removing the demerits and adding the upgrades. So version 1, version 2, version 3. So what are the things identified? Our system is vulnerable. How to remove the obsolescence? So that is important. And after removing the obsolescence, going to the new technology or new concept or new idea. So that is life cycle of a system. So apart from that, we have different life cycle of engineering approach: design, manufacture, deployment. So we'll see step by step in a life cycle. First, things should be designed. If you are become software engineer, before start developing a wireless transmission of energy, so what kind of design you need? You need energy. It should be that should be transmitted into uh, medium. That medium should be transmitted to the end user. So we need a medium to transmit the energy. So what that is designed in the designing part. Okay. So need, conceptual and preliminary design, detailed design, production, and product use phase, out and disposal. Okay. So maybe some project will complete in 6 months, some project will take 6 years or 16 years also. But this is a continuous development. In what is the need? A public need is wireless access of energy and step-by-step execution. So design, detailed design, production, and product. Okay, how it is manufacturing? In manufacturing, we have configuration. Okay. Yes, we need a Snapdragon 68 processor, and RAM is 12 GB RAM, and how it is used for the manufacturing operation, how to receive the material, whether it is OLED or LED monitor. So these things will be discussed. And finally, deployment. So product support configuration and design and development, product support and maintenance. Okay. So that will be coming under deployment, design, manufacture, and deployment. So these are the three different stages of life cycle of engineering approach. So demand and supply. So what is need and how to execute the need or how to find the outcome for the need. These are the two development phases and utilization phases. Okay. So this part you can see the red lines, okay, which are connected together and execute one by one. You will have a perfect system. All the system engineers must have the knowledge of development phase, utilization phase. And apart from that, another idea behind the system engineering is product life cycle identification of need. Yes, in current scenario for COVID-19, we need vaccination. Okay. So what is the vaccination? What combination it should be, and what will be the output? The output may be the vaccine will available in January or maybe July or maybe during 2023. Who knows? Nobody knows. Okay. So that's why that will be always stuff is called as preliminary design. Okay. In preliminary design, they will collect the samples and they will try with the different samples, and they will identify the structure of the virus and how to find the vaccine for the virus. Okay. So what combination to kill the virus, chemicals which is used to kill the virus. Okay. Then they will go for production and construction and utilizations of and support phase out and disposal. So these are the six phases or six development steps. We have to identify the problem and we have to identify the research input to get the output. Okay, this is called as product life cycle phase. Okay. So first phase we'll see the conceptual design. So where we need a system concept. So what is the idea? How to find vaccination? And between preliminary and detailed design development, subsystems, combinations. So the structure of DNA of the COVID. So then based upon the understanding the DNA structure, how to destroy or how to defeat the virus, the subsystem design will be done. Okay. And between detailed design and development and production, before production, a component design, a prototype model, okay, will be tested among different age group of people to really to reach to the end user. So component design will show the complete prototype, and these three phases is called development phase. Okay, system concept, subsystem, component, system, subsystem, component, subcomponent, and parts. So with last class we have discussed about these concepts. Okay. System domain will have the system, subsystem, component, subcomponent, and spare parts. Okay. So these are the step-by-step idea for creating a new design is called as development phase. And system engineering phases which have the basic steps, okay, that will be having the user need and user requirement analysis, function analysis, design synthesis, trade-off studies, and verify the baseline meets requirement. Finally, decomposition. Okay. So how it is reached to the end user. So these are the 7 different steps for basic steps for understanding a system engineering process. We'll see deeply in this slide. Input. So what do you exactly you need? We are going to a ATM machine. You are just giving input your ATM card, just swipe, and it will transmit the requirement analysis to functional design and synthesis, system analysis and control. So our output will be based upon these three. Okay. ATM will verify your username, password, and it will show the what are the functions you can take withdraw money. You can change your PIN number. You can transfer your fund. Okay. So all these things will be a functional analysis. Finally, if it will verify yes this account have this much amount, then you will get money. So these are the different 4 layers: concept studies, system studies, preliminary design, detailed design. Okay. These are the step-by-step execution for between input and output. Just we are giving some input, we are getting output. But behind that, these are the basic idea to retrieve the data or information. So this is the another typical concept behind the system engineering management. What we discussed in the previous slide, development phasing, system engineering process, life cycle approach. So this will be called as system engineering management. Okay. So each level have the different interactions. So how to apply SE process to development system in life cycle process. A life cycle process have the two important roles: conversion and obsolescence removal. Okay, the conversion takes place version 1 to 2, and obsolescence is removing the demerits from between version 1 and 2. Say requirement, development, verification, operation, development, and control. So put together, we say it is a system engineering management. So aids to system engineering management between development phase and system engineering phase is baseline. So what is baseline? It's a design and specification. It completely explains the specifications of the system. Okay. And development phasing and life cycle. So between we have life cycle planning. So what it does? So between development and life cycle is so drawing input from all life cycle activities for various development phases. A collection of inputs. And between system engineering process and life cycle approach, we have integrated approach. Okay, so multidiscipline. Multiple areas can work together, integrated together, interface processing method that is called as integrated approach. Okay, we can try to interface multiple ideas into a single system. Okay. So this is a very good example for a system engineering process mapped to life cycle. You can see need and key task. We need a CE and PD and EMD and PFD, and finally disposals. And apart from that, we need objectives, review, technical program, and change control. Okay, these are the both should work together to get a good system engineering process map to life cycle. Okay. So there are 22 different steps to achieve a perfect system engineering life cycle. Start from system analysis to replacement planning. Okay. The first phase, which is we are having, is to execute the data between different people, and so wait for a second. Okay, always, yeah, I'm going to be seeing always, having different users in the relating part. Always convey data would be always. Always. What is that? Yes, give it. Continue. Hold on. You don't have to read. After working, you ask for it. I really don't think it. Oh, yes. Yes. Yeah. You don't deny it. So, sorry for the delay. So there will be a different kind of ideas will be executing for the system engineering process map life. You are already seeing in the PPT. So 22 steps you can see in a single slide, where you can easily understand how step by step the data evaluation is done and concept design is done, and finally it is going for production. Okay. The first phase they will verify context idea. The second level we have that is second first phase actually. The zeroth phase we have analysis, and first phase we have design, And second phase, we have the manufacturing process. And third phase, we have production rate verification. So these are the four different phases for system engineering process mapped to life cycle. So this is the idea behind how a system engineering life cycle engineering process is happening in a real world. Okay, this is a complete process. What we discuss is a 24 process and four different phases, okay, which is working comfortably, okay, for the data transmission between user to development manager or development management team to the design team. So everything is working together to achieve conversion and removing the obsolescence. So this is the idea behind system engineering process or development life cycle. Okay. So do you have any doubts? Please ask me. Okay, and post the queries about the topic we have discussed. Tomorrow we discuss the complexity in modern system. So what are the complexities in modern system? So the PPT is available in our